If you think LLMs have been the pinnacle of AI with incredibly successful human-like text generation and prediction, think twice as now comes into the scene large concept models or LCMs. With this super interesting recent paper, Large Concept Models Language Modeling in a Sentence Representation Space by Meta researchers. Large concept models or LCMs can potentially become a revolutionary approach to artificial intelligence that's changing the way we think about language processing. So, what exactly are LCMs? Simply put, LCMs are a type of AI models that process information in a more human like way. For example, instead of breaking down language into individual words or tokens, LCMs focus on higher level concepts and ideas. This approach allows them to capture the nuances of language and understand the context of a conversation more effectively. Think of it like this. When you're reading a book or having a conversation, you're not just processing individual words. You're understanding the overall idea, the tone, and the context. That's exactly what LCMs do, but with a level of precision and speed that is unmatched by traditional language models. For a deeper understanding of LCMs, let's recap what we know of LLMs and how they work. Most large language models or LLMs rely on transformer-based decoder-only models that are designed to predict the next token or word given a long context of preceding tokens, or simply put, predict one token at a time. However, despite their impressive capabilities, LLMs have a fundamental limitation. They're only as good as the data they've been trained on. They can recognize patterns and generate text based on that data, but they don't truly understand the underlying concepts or context. Due to this architectural limitation, even the best LLMs lack a fundamental human characteristic, which is explicit reasoning and planning at multiple levels of abstraction. That's because the human brain does not operate only at the word level. We usually have a top-down process to solve a complex task or compose a long document. We first plan the overall structure at a higher level and then step by step add details at lower levels of abstraction. But even more important than that is how the human brain keeps track of dependencies. Unlike LLMs, we do not process one word at a time. Humans are good at remembering dependencies between different parts of a document, movie, or song at an abstract level. This is because human brain has a hierarchical approach to processing information. For example, we can remember which part of a document or movie to search for the information or which part of a store to search for a product we need. While some LLMs can learn this hierarchical representation implicitly and by way of a huge amount of data training, giving the model an explicit structure for hierarchical processing is what makes them significantly better at contextual understanding. This is where large concept models or LCMs shine, processing and generating information at an abstract level due to the hierarchical reasoning in an abstract embedding space, regardless of the language or modality in which it's generating the information. In the LCM architecture, a concept is an abstract idea but corresponds to a sentence in a document or utterance, where the sentence embedding is obtained by training an embedding space with SONAR that supports more than 200 languages. For example, in this embedding space for a summarization task, the reasoning is achieved by mapping 5 concept representations into 2. To arrive at this point, in the LCM architecture, the input text is first segmented into individual sentences and then encoded with SONAR or the embedding unit to convert this sequence of sentences into a sequence of concepts. This way, instead of focusing on every word in those sentences, the model focuses on the main ideas in those sentences and then generates an output which is also a sequence of concepts. Finally, SONAR decodes those output concepts and turns them into a sequence of subwords that can be understood by humans. The beauty of this system is that because till the output, this processing is done on the concepts rather than individual words of a particular language. Once we get the output concepts, we can turn them into words in any language we want or even convert these concepts to other modalities such as image or audio. This is something that LLMs couldn't do because they were processing individual words of a particular language one at a time. But the LCM's architecture only works on the concepts, so it doesn't matter what language or modality it receives as input and what language or modality the output has to be generated to. So basically, we have concept encoders and decoders. The result is that now we have a generative model with an explicit hierarchical structure that can reason at an abstract level, regardless of the input or output language or modality, and therefore can handle very long context as input and produce very long output, even at zero-shot attempts. Apart from the base LCM, the authors also trained the LCM prototype on various diffusion architectures. Diffusion-based LCMs are generative latent variable models that learn a model distribution approximating a data distribution. The diffusion LCMs are also autoregressive models that generate concepts in a document one at a time. If you've been hanging around my channel for a while, I explained that the diffusion models that are famous for generating images basically take the input, usually in the form of a text, and gradually remove the noise from the base noisy image to obtain an image that is described in the input text. Just as diffusion models were trained to remove the noise from an image to get a clear image, the large concept models based on diffusion learn to remove the noise from concepts one at a time. As you can see in this one-tower LCM architecture, the model receives these concepts, timestamps them, and removes these noisy concepts. Then the transformer decoder in multiple denoising steps arrives at a clear concept. Sounds cool, right? Large concept models have managed to reach human-like reasoning capabilities and can delve into more abstract ideas when summarizing text or generating answers. Let me know if you want a more detailed video about this, but for now, take a look at this video about the most important and fundamental AI and machine learning papers and concepts that you need to know.